In this video, I explain an application problem involving two annuities. The problem says, Mei Li invested $350 at the end of each quarter at 3.2% compounded annually. At the end of 5 years, she could withdraw equal amounts at the end of every 6 months for 9 years. How much is the size of each withdrawal? Notice that in the time that we have, there are 5 years in which Li is investing $350 at the end of each quarter. So that happened for 5 years. They say that at the end of 5 years, she could withdraw equal amounts at the end of every 6 months. Obviously, after this annuity, this 350 deposit every quarter, she's going to have an amount, a future value here of this annuity. And this future value that we're going to compute will be the present value of a second annuity in which she is withdrawing money. And that's happened for 9 years. So it's going to happen in 9 years. They say here for every 6 months for 9 years. So, and this withdrawal is at the end of every 6 months. So it will be at the end of the first 6 months. It's going to be a withdrawal. Let's call it R, and etc. So until the last moment when she doesn't have anything in the account. So we want to compute what is this R. So reading the problem, we understand that this is the situation. We have two annuities. So we are going to compute the future value of the first annuity because we have the payments. And with this future value, we are going to compute the payments, but taking into account that this future value is now the present value of the next annuity. So let's do it. So we are going to compute the future value of this Sn that we know the formula. Payments 1 plus I to the power n minus 1 divided by I. This future value will allow me to obtain this value here. That will be the present value for the next annuity. Okay, so what we have here, the payment is 350. Let's take note this for the first annuity. Payments are 350. And the number of payments per year. So we noted that these payments are at the end of each quarter. So there are 4 payments per year. So type here that K, number of payments per year, are 4. Obviously, because that happened for 5 years, then the total number of payments on this first annuity is 20. So this 20 is going to be here, and this R is 350 will be here. The rate of interest is 3.2% compounded annually. So we know that the rate of interest is 3.2, and this compound 1 per year. So I noticed that 1 and 4 are different. So the number of conversion periods and the number of payments periods per year are different. So this is a general annuity. How to compute I in this case? Using this formula. We know that K is the number of payments and M is the number of conversion periods per year. K, number of payment per year. M, number of conversion periods per year. And R is just the nominal rate of interest. So when we make a substitution, we have a 1 here. We don't need to type it, 0.032. But this one here is important. It's 1 over 4. That is 0.25. So you actually can make a computation of this in your calculator. And you will notice that the answer is this 0.007905753. So this is the one that you need to put here. So make a substitution of everything you know in the formula. So I is this number, R is 350, and N equal 20. So when you make this computation in your calculator, you will notice that the value will be this, 7,551.53. So this is the amount that Mrs. Li had here at that point, 7,551.53. And we want to know then what will be the value of this payment. So now we need to think in the second annuity. What will be this 7,551 will be the present value of this annuity. So let's go to the next annuity, because in the next annuity is when we are going to compute this R. So let's here type that for finding the payment in the next 9 years, the second annuity. So we're going to have this 7,551.53, that will be now the present value. And this is the formula that I'm going to use, present value now. So in the previous part, we use the formula of future value, but now we have, for this annuity, we know the present value. So we are going to be using the formula of present value in this annuity. So the present value is this, and we are going to solve for R. I know that I need to multiply by I and divide by this expression here at the top, this factor here at the numerator. So solving for R, that will be the answer. And we know AN, that is 7,551.53. We also know the number of payment per years, because that's going to happen at the end of every 6 months, they say here. She could withdraw equal amount at the end of every 6 months, so twice per year. K, in this annuity, K will be 2. And the total number of payment will be 9 times 2, so that will be 18. And this 18 is the total number of payment that appears here in this formula N. And to know this I, we know that we need to check again the conversion period at this point. And I noticed that it continues being the same interest, 3.2 compounded annually. So R equal 3.2 and N equal 1. I is going to change now because now K is 2. So if we make a substitution in this formula, that is the formula for the periodic rate of interest compounded as many times payments per year. So this M will be 1, but this K will be 2 now. So it will be this number. Make a substitution in your calculator. This 1/2 is just 0.5. This is just 0.032. So when you make the computation, this is the number, I guess. Put it here in the formula. I did it. So I put everything in the formula. This AN is now 7,551.53. And this N is negative 18. Use again your calculator, and you will notice that the final answer will be 485.615296. Rounded to 2 decimal will be 62. So the quarterly deposits that we have at the beginning accumulate to 7,551.53, which will be sufficient to provide semi-annual withdrawals of 485.62 for 9 years. And that answers the question of this problem. And with this, I finish my explanation. Thank you.